Hello, everyone. A very good morning. Welcome back to the Pharma Analytics session. Today, we will be continuing with the supervised learning techniques and also we'll be moving ahead with text mining. So, just to give you a close recap about what happened yesterday, we tried to see what are the different methodologies, and we also saw the CRISP MLQ technique. Then we moved ahead to learn about the machine learning algorithms. We saw about the supervised learning and unsupervised learning. In unsupervised learning, we saw an example wherein we saw how clustering works, mainly the k-means clustering. And today we will be moving ahead with supervised learning, and that we'll be dealing with regression analysis. Give me a second. Yeah. So machine learning algorithms, in that we saw about supervised and unsupervised. Okay. We apply unsupervised techniques or unsupervised learning when we don't have label in the data. Okay, when there is no label, you can tell it as an output variable also. So in the data, there is no label, and we are just directly giving the data to the model, and the model will try to learn the hidden pattern in the data and try to group it. Okay. So this is about unsupervised learning. Yesterday we saw the k-means, wherein k stands for number of clusters. So we had defined a few number of clusters, and the whole data was grouped into those many number of clusters. Okay. Now, the main goal is to summarize over here. Whereas moving ahead with the supervised learning, in supervised learning, we have an output variable or the data is labeled. Okay. We have something called y by column, and we are predicting on this. Okay. Firstly, we train the model with the data. Say if our data has multiple columns, x1, x2, x3, x4. We also have y variable or the output variable and the data. We take this data and train the model. So in this, the model tries to learn the relationship between the y, which is the dependent variable, and the independent variable, that is x1, x2, x3, x4. So the relationship between these and how the x variables are affecting the y is learned by the model. And then the model will give us a mathematical equation so that we understand the relationship between these two. Based on this equation learned, the model will be able to predict on the new data. This is the outline for supervised learning. We also saw the primer for supervised learning yesterday, wherein the data is divided into train, test, and valid. Okay. First, we split the data into train, test, and valid. Maybe around like 80% would go in train and 20% in test or valid. Or you can divide it like 60% in train, 20% in test, and another 20% in the validation. So first, we train the model with the 60% of data. In the 60%, we pass all the x variables and the y variable too. Okay. By this, the model will have learned the pattern using the mathematical equation. And after learning, we check for the accuracies. Now, we also try to validate. So here, we send the other 20% of the data into the model and validate. The model gives us some accuracy, and based on this accuracy and errors, we can tune the model. We can adjust some of the hyperparameters and increase the accuracy. Once this is done, we can try to predict on the new data. When you pass new data, the model will be able to predict the appropriate y value for that particular variable. So this is how supervised learning works. In supervised learning, we are talking about regression analysis today. Now, we apply a regression analysis when we want to predict our y. Okay. Now, this prediction is based on a independent variable. Now, say there are two continuous variables, x and y. Okay. And the relationship between x and y is found out. Okay. If the increase in x will directly impact the y, it may increase or decrease, or whatever that is, the impact or the relationship between x and y is found out, and for that, the model generates the equation. Okay. So here we are trying to see the relationship between the dependent variable and the independent variable. Our dependent variable would be y and the independent variable would be x. Okay. So here we are predicting the dependent variable. What is our dependent variable again? It is the y. So overall, we are predicting the y. So what is the agenda for today? Now, we'll be learning about the equation y is equals to f of x. Then we'll be moving ahead with the scatter diagram, correlation analysis, then equation of a straight line, ordinary least squares, regression analysis, dummy variables, and a simple use case using simple linear equation. Then about the transformations and bias and variance. So this is the agenda we are going to cover in the regression analysis. Now, y is equals to f of x. This is the base equation we are trying to depict. Now, this states that any change in x will create a change in y. And we are trying to see this relationship between these two variables. Okay. So y is the function of x. Any change in x would produce a change in y. Now, moving with scatter diagram. What are scatter diagram? Scatter diagrams are plots. Okay. Here, you can graphically represent the relationship between two continuous variables. Say, here there is x, here there is y. Now, taking these two variables, you can find the relationship between these two variables. Okay. How to understand the relationship? Say, if one data point is here, okay, x is, let me add some values. Okay, when x is 1, y is 1. And there is another data point, x is 2 and y is 2. There is another data point, x is 3 and y is 3. So here we can see that as in how the value of x is increasing. Okay, even the y is increasing. Okay, there's the direct linear relationship between x and y. Okay, this is how you can find the relationship between two continuous variables with the help of scatter diagram. When I say continuous variables, it is numerical data that when expressed in decimal format also makes sense. So usually regression analysis is for continuous data. Okay. Now, there can be other relationships between x and y also. See, here there's one data point, another data point, another data point, and another data. So, in this, you can see with the change in x. At this data point, the value of this data point is 1, 4. So now, as in how the x is increasing, the y is decreasing. Now this is 2, 3. Then there is 3, 2. So the y is, so there is inverse relationship between x and y. As the x increases, y is decreasing. Though there is inverse relationship, but there is a relationship. So with the help of scatter diagrams, we are trying to find these relationships. Okay, this is a strong positive correlation wherein increase in one variable is producing a change in another variable positively. Then there is negative correlation, as we saw in the second example, where increase in one variable is producing decrease in the other variable. This is also a correlation. Now, if the data points are closely clubbed, this means that there is strong correlation. If they are scattered a bit, then it is moderate. If all the data points are scattered and you cannot find a relationship. You cannot tell that, okay, increase in this is increasing this, or there is the data points are scattered, then there is no correlation between the x and the y variable. There's no exact relationship between these. You cannot say that x is increasing due to y or y is decreasing due to x. Then again, the same applies here. If they are closely clubbed, and one variable is decreasing with respect to the other variable, then there is strong negative correlation. Then there is moderate negative correlation, and there is curvilinear relationship also, wherein first it is decreasing and then there is a sharp increase. So whenever we are doing the regression analysis, mainly we are trying to find an equation or a dependency. Okay, like if there is a dependency between x and a y, then only we can put it into an equation and predict the new one. So to find that relationship, we first go for scatter diagram to see if there is any relationship between them or no. Okay. But then this is not the complete picture. By using scatter diagram, you may or may not get the complete picture, but the initial step would be to take a scatter diagram. Okay. Now, we judge strength of relationship by width or tightness of scatter. Now you can see this is tightness. If the width increases, then it is scattered and it is moderate strength. Okay, so here we determine direction of the relationship. Okay, if x is increasing and y is decreasing, x is increasing and y is decreasing, it is negative correlation. Again, if it is strong or moderate, we can tell only by seeing the scatterness or the tightness of the scatter. Then, if x is increasing along with y, then it is positive correlation. The strength again can be set due to by the tightness or scatter. Okay. Now, so with the help of scatter plot, first thing we are seeing is the strength relationship. Like if it is positively correlated, negatively correlated, strong positive or strong negative. Okay, then one thing about this is the correlation does not guarantee causation. Okay, correlation by itself does not imply a cause and effect relationship. Sometimes what happens, there might be values of x which keep increasing, and when you plot it, y also keeps increasing. Though the scatter plot shows that there is a correlation, it might not be the reason for cause. Okay, it does not guarantee that x is increasing and y is also increasing because of x. So causation is not guaranteed by the scatter plot. It might be due to some other reasons. Okay. But still, you can see the sharp increase. So the reason is not guaranteed. So first step would be to analyze it using a scatter diagram, but we are not coming to a conclusion that that is causing the increase. So with the help of scatter diagram, first thing is we see the strength, then we move ahead with the direction, positive or negative, and we can also see the linearity. If there is a linear relationship between these two variables, there is a linear relationship, then we can find the relationship between these two variables with the help of a straight line. So if there is a relationship between two continuous variables and there is a sharp increase in one variable with respect to the other, and this can be linearly interpreted, then we can predict new values with the help of the linear equation or equation of a straight line, which is y is equals to mx plus c. Now, the drawbacks of the scatter plot would be, first thing is it is subjective. Okay. Why are we telling that it is subjective? Say, for example, this is the scatter plot. Okay. We can say that there is a positive correlation. Increase in X is increasing Y. There is a positive correlation. But when it comes to the strength, I may say this is strongly correlated. But someone among you may say this is moderately correlated. Okay. So this is subjective. Okay. It differs from person to person. So because of the subjectivity, we need a proper measure, like to say, okay, this is strongly correlated and this is not. So to avoid the subjectivity, we can go for correlation coefficient. Okay. Now, correlation coefficient is given by small r. Okay. The range of this correlation coefficient is -1 to +1. If R value is almost near +1, then it is a perfect positive relationship. Okay, the strength is very high. Whereas if it is -1 also, it is perfect negative relationship. If the R value is 0, then there is no relationship between them. Okay. If the absolute value, R value, if it is greater than 0.85, when we say absolute, we are taking this positive values only. So if the value of R is greater than 0.85, then it is a good relationship. Okay. Now, R is equals to 0.87, R is equals to -0.9, R is equals to 0.9, or R is equals to -0.87. All these are good relationships. Like the X and Y are linearly correlated. If the R value is less than 0.5, 0.5 or -0.5 or 0.228, this describes poor relationship. If it is 0, there is no relationship between those two variables. So if the correlation values are -1 or +1, then there is an exact correlation. Okay. So if there is positive correlation, then you can see there's perfect linear correlation. Okay, linearly both are increasing. This is in case of +1, when R is equals to plus. R is equals to -1. That is a perfect linear but negative correlation. However, the real value of correlation is quantifying less than perfect relationships. Okay. We can perform regression analysis, which attempts to further describe the type of relationship if the correlation is good between the two variables. Why are we studying about all this? Why scatter plots? Why correlation? Because in regression, we are trying to see how y is changing with respect to x. If there is any correlation between these two, and mainly if the correlation is linear, then we are telling that we will fit this into the equation of straight line and try to predict on the new values. So now, this is the formula for R. The small r, which is called as correlation coefficient. This is the formula, how it is calculated. We need not by heart the formula as it is uh, calculated in Python itself. So this gives us the relationship between the two variables. Now, if it is positive correlation, then it looks somewhat like this. Here, the value of R is 0.4. Now, when R is 0, there is no correlation. You can see the X and Y are nowhere increasing or decreasing with respect to each other. Then this is no correlation. Okay. Next, when the value of R is minus 0.4, okay, you can see there is negative correlation between the two variables. With increase in X, the Y is decreasing. Though there is negative strength, negative direction, but still there is correlation between the two variables. Okay. Next. So in linear regression, we are assuming few things. Okay, if we are applying linear regression model, we're assuming that both the variables are linearly dependent. Okay, so we are telling that it is linearly dependent, which is why we are taking the equation of a straight line. As we studied, how is the equation of straight line? In our primary classes, we studied that equation of straight line can be expressed by y is equals to mx plus c, where m would be representing the slope, right? And c is the intercept. So if this would be our intercept and this would be our slope. Okay. Now the same equation of straight line, we are taking and writing it over here. Okay. So this y variable is dependent on beta naught plus beta 1x plus epsilon. This is the intercept and this is the slope. Okay. If I have to denote this, this would be our x, this would be our y, this would be beta naught, this would be the slope. This slope can be calculated by using this minus this value. And epsilon would be the error term. Okay. This is the equation that represents how an independent variable is related to a dependent variable, and an error term is a regression model. Okay. How this x is related to y is what we are trying to see. These are the equations for beta naught and beta 1, and this is how beta naught and beta 1 are calculated. So once we apply regression, the model will give us the intercept values, beta naught, and also the coefficient value, that is beta 1. These values will help us or will help the model to predict on the new data. Say for example, I have a certain values. Excuse me. Yeah. So I have few x values and then y values with respect to that. Now I have trained the model and even found the equation plus e. Okay, this is the straight line. We found that there is a linear dependency between these 2 points, and that linear dependency is expressed in terms of the equation. This equation will tell us what would be the value of beta naught and beta 1. This is just an example I'm taking. Now, with the help of this equation, I can predict any new value which will be given. If this is used for the training, now any new value which is given, I'll be able to predict. Now, if they have given a new value, 12. For this new value, we'll be able to predict what would be the value of y with the help of this equation. So, substituting 12 over here, we'll get the value of y. Say, for example, this is 20. That is how you can predict on new data. Now, the technique we use is called as ordinary least square method. The technique which is used for regression analysis. Why is it called ordinary least squares? Let us see that. Now, these are the blue points here are the data points. Okay, so our data has these values. Say, for example, this is the value of x over here. This is this one. The value of y here is 4. The same way, x and again y. So all these data points exist in the data. We are trying to analyze the relationship. Now, how is it correlated? Firstly, there is positive relationship between these two data points, and it is moderately correlated also. Okay, linearly dependent on each other. So we can put a straight line. Okay, we are fitting a straight line which will be able to cover all the data points. Okay, by using regression analysis, we are trying to find a best fit line. Okay, so we are telling that this line equation will include a lot of data points, and this can predict new data points also. Okay, now this is our best fit line. How can we tell that this is our best fit line? There might be many line equations which can be found out is here by the model. But which line would give us the best fit? How is this found out? The best fit line is found out by the error term. Okay. Now, what is this error? If this is the line equation which we are trying to fit, okay, we see the errors. This is the actual point, and this is the predicted line by the model. So we try to see the error. The distance from the actual point to the predicted line would be the error. And we try to minimize these errors. Okay. When we try to take the aggregate of these values, we want the error to be very less. Okay. When the error is found to be very less, and then that particular line would be our best fit line. Okay. So the distance between the actual data point and the distance between the predicted point. This will give us the error, and we try to minimize these errors. Now, if we take these errors, here there are positive errors, and here there might be negative. So once we are calculating the errors, say this is our actual y, this is our predicted y. If we calculate the errors, the sum of it, if you try to take, would actually come to 0 because there are positive errors and negative errors might come to 0. So we usually take the square of the errors. That is why this technique is called as ordinary least square. Okay. So we are fitting a straight line. This is the straight line which we fit. And if we tell that this is the best fit line, it is because after calculating the errors, this was the line which was found to have least errors. When we say least errors, it means that almost all the predicted data points fall on the straight line. Okay, so the predictions are correct, or the relationship is found out appropriately. Now, R squared is also known as coefficient of determination. Now, R squared is the value which we see to understand how good the model is. This can also be called as goodness of fit. Okay. So, also known as coefficient of determination, it represents the percentage variation in output variable explained by input variable. Okay. So, how much x is varying with respect to y. So, explained by the input variables or percentage of response variable variation that is explained by its relationship with one or more predictor variables. Higher the R squared value, better the model fits your data. Okay. So the R squared value always falls in the range of 0 to 100%. Higher the value of R, better the model is fitting our data. Mathematically, how is R squared calculated? This is the formula for R squared. SSR by SST. Sum of squared residuals by sum of squared totals. Now, SSR is calculated by y hat minus y bar whole square, and SSE is calculated by y minus y hat whole square. Okay. Substituting that into this equation, you get the measure of R squared. R squared will always be in the range of 0 to 100%. And if it is more than 0.85, then there is strong correlation. The model is fitting well to your data. If it is in range of 0.4 to 0.85, then there is moderate correlation. Okay. So to evaluate how the model is fitting our data, we go for the R squared value, just the coefficient of determination. Before going into the use case, let me summarize what all we have learned until now. Okay. Firstly, think there are two variables, x and y. Okay. We want to find the relationship between x and y. So to find this relationship, we plot these two variables on the scatter plot. Scatter plot is a bivariate plot wherein there are two variables can be fit on it. Now, the scatter plot will give us an idea of the relationship between the two variables. It may not actually say the causal relationship, but we'll get a brief idea about how they both are related. So the scatter plot, we can come to a conclusion if there is a strong correlation, weak correlation, or a moderate correlation, and even the direction, like whether it is positively correlated, negatively correlated. If the data we are looking out for has linear correlation, if the increase in x is either directly increasing the y or increase in x is directly decreasing the y, that is linearly decreasing it, then we can call that there is a linear relationship between these two variables. Once we establish that linear relationship, we can go for correlation coefficient also, as scatter plot is subjective. Subjective in the sense the scatter plot, if we say that some variables are strongly correlated, some variables are moderately correlated, again it is subjective. I may say that it is strongly correlated and some other person may say it as moderately correlated. So because of the subjectivity in there, we are trying to go for correlation coefficient, that is smaller. Correlation coefficient will give us a numerical value of how strong the correlation is. So because it is statistically analyzed, we can directly understand the relationship. If the correlation coefficient is greater than 0.85, then you can say this is strongly correlated. It can be positive 0.85 also and negative 0.85. So it is positive 0.85, then it is strongly correlated, strong positive correlation. It is minus 0.85, then it is strongly correlated but negative, strong negative correlation. So in this way, we can use correlation coefficient to see if there is relationship between those two variables. Once we establish that there is a correlation between them and that might be linear, then we can move ahead to build a linear regression model. What exactly are we doing in a linear regression model? After finding out that the x and y are dependent, meaning when once x is changing, the y is also changing. It might be positive or it might be negative. So this we are trying to express in terms of the straight line equation. The relationship between these two, you are trying to explain it through the help of a straight line. So this straight line equation, we try to find the best fit line. Okay, there can be straight line here, this can be straight line here, there can be here. Which is the straight line which is best suiting our data is found out by the help of ordinary least squares technique. What is ordinary least squares technique? Now, if these are the actual data points in our data, and this is the predicted line, Okay, this is the predicted line which our model has given us. We see that the error, that is the distance from the actual point to the predicted point. This error is what we are trying to reduce. So whichever line which gives us the least error is used as the best fit line. Okay, so this line will predict well. That is why this technique is called as ordinary least square technique. Now, R squared is also known as coefficient of determination, and it will tell us how well or how good the relationship is between the variables. Now we are going to discuss a simple use case. This is again using healthcare data. Now, adipose tissue. What is adipose tissue? Adipose tissue is nothing but the fat tissue. Okay. Studies have found out that people with the excess adipose tissue, mainly in the abdominal region, the stomach area, in this region, people who had a lot of adipose tissue had a higher risk of developing cardiovascular diseases. Okay. Meaning, if the fat tissue in the stomach area was high, then there was an increased risk of cardiovascular disease. What are cardiovascular diseases? Nothing but heart diseases. Okay. When there was direct relationship between these two, then to prevent heart diseases, we need to see the people who have excess adipose tissue, and we could try to prevent them from getting heart disease. Right? The relationship between the adipose tissue and cardiovascular disease was found out, and then to prevent this, we could indirectly prevent adipose tissue. But this adipose tissue can be only calculated with the help of CT scan. Okay, only with the help of CT scan, we can know the precise and reliable measurement of the adipose tissue. There was no other way to find out the percentage of adipose tissue in patients. And because CT scan was the only way to find out, doctors were facing issues as the CT scans are not available everywhere. The machine was very costly, and not all our hospitals or not all physicians have access to this technology. And another thing is, if you expose patients to CT scan every now and then, it is not good for their immune system. Okay? Because the CT scan contains those radiations which will suppress the immune system. That was also a issue. That was also a problem which our patients were facing. Then CT scans are also expensive. Okay, these were the issues which our physicians were facing. We want to find out the adipose tissue and also reduce the risk of heart diseases. But a CT scan was the only option, and we have so many issues with the CT scan. So more of a research was being done in this area so as to predict the or you know try to understand how the adipose tissue is. So with study research were being done for a simpler way, which should be also accurate to predict the adipose tissue. These simpler techniques would be easily available, risk-free, or inexpensive. Okay, research was going on to find something in this area which is easily available, risk-free, and is inexpensive. Now, a group of researchers found out that abdominal tissue or abdominal adipose tissue was correlated with the anthropometric measurements. Okay, adipose tissue was linearly correlated with the measurements of the body, say mainly the waist circumference. Okay, if the waist circumference is more, then the adipose tissue was also found out to be more. By this new concept or this new research, that was found that there was a correlation between the adipose tissue and the waist circumference. Then the correlation between these two was studied so that the risk of heart diseases or cardiovascular diseases were reduced. Yeah. So the waist circumference adipose tissue data is a part of the study wherein the aim is to study how well waist circumference predicts the abdominal adipose tissue area. Okay. So heart diseases were found out to be more in people with increased adipose tissue. But to find this adipose tissue, CT scans were the only way. So researchers came up with a new study wherein they found that this adipose tissue is directly dependent on the waist circumference, meaning if a person's waist circumference is changing, then also the adipose tissue is directly changing. They found that the correlation or a linear relationship between these two. Now, this was extensively studied so that adipose tissue can be reduced and indirectly reduce the heart diseases. But the problem they were facing was in the data. How to now understand how these both are related. Okay. Now, to get the proof, you will need adipose tissue also and waist circumference also. Unless you have the data for both, you will not be able to establish the relationship between these two. How can we find both the data? Okay. For adipose tissue, we will have to depend on the CT scans only until we discover a particular relationship. So the adipose tissue values were taken from the past patients. Okay. People who had undergone CT scans and who had adipose tissue values in them, those were taken and the waist circumference of those people were also considered. Now, the patients who had undergone CT scans in the past may or may not have their waist circumference because nowhere they check for waist circumference. So, collecting waist circumference would be challenging. One way would be to again call up the patient and ask them to come for the uh, of the waist circumference, or you can invite them for a free health checkup and then go for taking the anthropometric measurements of those patients. Once you have the data for adipose tissue and the waist circumference also, then we can build a model to find the relationship between those two and see how well they are correlated, uh, how strong the relationship is between these two. Once we establish the relationship between these two, then we can prevent people with a higher adipose tissue from heart diseases. So this was a simple use case wherein we were trying to predict the adipose tissue. Now, this was the data collected. There were data for 109 patients. The value of the waist circumference. Patient who had a 74 had the adipose tissue value of 25. So all this can be plotted, all these data points for 109 patients, and you can find the relationship. Now, what are the key takeaways we have learned in this? First thing about the function y is equals to f of x. How y is dependent on the x, or how change in x is changing y. We understood the interpretation of relationship between two continuous variables. How do we interpret? We go for the scatter plot and also see for the relationship x and y. Continuous variables is nothing but numerical data. Mainly, continuous variables would be numbers which can be written in decimal format and would be making sense. Okay, this doesn't involve count data. Then we learned about scatter diagram and the measure of correlation. Scatter diagrams are bivariate plots and how well they are correlated, like strong, moderate, weak, or no correlation. Okay. Then, now, if the data has categorical values or discrete values, we saw that x and y were numerical. So we were able to put it in the graph. Now, what if we have dummy variables? What if we have categorical data? If data had text or discrete data, then we can apply dummy variable creation, convert this also into the numerical data, and then apply the regression. Then we learned on how to predict a continuous dependent variable using ordinary least squares technique. Now, we also understood the partitioning of the data. We're dividing the data into train, test, and valid. Then we learned about how to develop a linear regression model using trained data. Then we learned about coefficient of determination, that is R squared. Okay, if R squared is more than 0.85, then there is good model. Now, we also learned about how to measure and increase the accuracy of linear regression model using test data. The accuracy is less, then we go for hyperparameter tuning and then increase it. Then we'll understand about the overfitting and underfitting. Okay. Let us move to the code part of the linear regression. In this code, we will try to see how to see the relationship between two variables. Then how to find the correlation coefficient. After doing all this, how to build the model, and then how to train it, test it, and then tune it. Now, I am using a spider ID. There are various IDs you can use. So for this, I'm using spider ID. And for the next example, I will be using Google Colab. So firstly, we import the necessary libraries we need. Okay. So Python provides access to the libraries, and we can directly use those libraries and the functions inside them so that our problem is solved. Now, first we are importing pandas as PD. Pandas is one library which is mainly for data frames. Okay. There's a data frame, and any change you want to do with the data frame, you can use the pandas library. Then there is matplotlib. This library, matplotlib, is mainly used for data visualization. Okay. If you want to visualize the data, you can go for matplotlib. Then there is sklearn. This is mainly used to build all the machine learning algorithms. From sklearn, you are importing linear underscore model. So whenever we write the code, first we try to import the necessary libraries which we think will be used. All libraries might not be possible at the first go, because as in how you will be adding new lines, you will be understanding what libraries you are going to need. So we just leave some space so that we can add some libraries later. So whatever is required, whatever you feel is required, first we try to import those libraries. So we are importing pandas, matplotlib, and sklearn. So these three libraries are imported into the session. Now, I am loading my dataset. My dataset is in the CSV format. So I am using a function read underscore CSV, which is a which is in the function in the pandas library. Because I have imported pandas as PD, I'll be using PD as to call that particular library in the code. So pd.read underscore CSV will take this read underscore CSV function from the pandas library and read my file. If this file was in Excel, I would go for read underscore Excel. Okay. Now, I'm reading the data. So the data which was in the CSV format will be read and stored into the data frame called data. So this is our data. This is of data frame type, and this is the size. Okay, there are 12 rows in this data and 2 columns. That is the size of the data frame. And the column names are time and potency. So the two columns are time and potency. Now you can see these are the two columns. This index column is inbuilt in Spider. It is not a part of our data. Our data is only this much. This data is mainly related to drugs, the shelf life. So here, the time the drugs are kept and their potency. Both are analyzed. Okay. Potency, you can call it as efficiency. Okay. Give me a minute. So we have two columns, X and Y. One is time and one is potency. So you're trying to see the relationship between the time a tablet is kept and how the efficacy is of the tablet, how effective that is. Okay, and the relationship between them. This would indirectly help the patients, like if by the study you can understand what would be the shelf life of that particular drug, or by when should that particular drug or medicine should be consumed, or it will also help the pharma companies understand how much should they store for how long. So for all these, they can use a linear regression to find the relationship between those two variables and then take appropriate decision. Okay. We have stored that in the data frame called data. If I call it, I can see all the values over here. Time and potency. Now, data.shape. Data.shape will give us the shape of the data frame. So the data frame overall has 12 rows and 2 columns. These are rows, these are columns. Moving ahead, we will be plotting this. Okay. As we saw, first thing we do before applying regression analysis would be to plot a scatter plot. Scatter plot is bivariate plot. Now, plotting this, now on the x-axis there is time, on y-axis there is potency. Okay, you can see this is how they are related. With increase in x, is the y increasing or decreasing? The y is decreasing. Say for example, x was 5, then y was 99. And then as in how time passed, the efficiency or the potency decreased. Okay. So we are plotting a scatter plot to understand the relationship between the time and potency. Which is the library we are using to plot the scatter plot? We are using matplotlib library, plt.show. So we have imported matplotlib library as PLT. So whenever we want to use this PLT, matplotlib library, we go for PLT. Okay. Now, once we have seen that there is a relationship, okay, it is not scattered. The data points are not randomly scattered. There is a relationship, and that relationship here is negative correlation. However, there is a relationship. So, how to judge if this is a strong, moderate, or weak correlation? I may say this is strong. You may say this is moderate. How to judge this? We can go for correlation. Okay. Now, before that, we are plotting a box plot. This is the box plot. Box plot is plotted to find the outliers. Okay. Again, we are using the matplotlib library to see the box plot. Okay. Usually, box plot is plotted to see the outliers in the data. What were outliers? As discussed yesterday, outliers are nothing but the extreme values. If there are any extreme values, they will be seen over here out of the box, and these values will affect our calculations. That is why we usually try to treat the outliers. Now, in our data, there are no outliers, so we can move ahead. This is the box plot for time. This is in this range, 10 to 70, and then potency is in this range of 90 to 102. We found out there are no outliers. Next, we are going for correlation coefficient, that is smaller. To calculate correlation coefficient, we can use a built-in function, that is CORR. Data.cor. Data is our data frame, and .corr with a parenthesis will calculate the correlation coefficient for this data. If I try to execute this, you can see in the console, this is the correlation. Okay. So we can ignore this because it is time and time correlation is 1, and potency and potency correlation is 1. So we are just seeing these. Time and potency, the correlation is minus 0.79. Okay. So we said if it is more than 0.85, then there is strong correlation. 0.79, maybe there is moderate correlation. What does this negative value indicate? Means that they are negatively correlated. We already saw in the scatter plot too. Increase in X was decreasing Y. So the negative correlation, and there is also moderate correlation between two variables. Okay. Now we have found out that there is correlation. So we can also go for regression analysis. Simple linear regression. Okay. To apply this simple linear regression, there are multiple ways. We will see them one by one. First, because both the columns, the X and the Y, are in the same data frame called data, we're trying to put both the columns in different data frames. Now, PD is again Pandas library. From Pandas library, you're taking the data frame function and then taking one column from the data. So data is our data frame. From that, we are taking only time column. Data of time. We'll take the time column and store it in the data frame. And the name of this data frame would be T. The same thing, potency column is taken from the data and it will be converted into data frame with the name P. Let me execute this. This is our data frame, which has time and potency, which has around 12 values, 12 rows and 2 columns. Now the same thing we are converting into 2 data frames. T would be our first data frame. So you can see only the time column is taken and that is put into a data frame called T. Okay. Next, we are going for creating another data frame with a potency column. Potency is nothing but the efficiency. So that would be P. Another data frame got created over here. This is the potency. You can even just call them and see the values. This is the T data frame and another one is P data frame. Why are we dividing them into different data frames? So that we can pass these into the model. Okay. As we are trying to build linear regression model, we will first initiate it. Okay. So linear underscore model dot linear regression. From where did we get this linear underscore model? We have imported this from sklearn. Okay, sklearn import linear underscore model. From this linear underscore model, we are taking the function linear regression. So this is how we are initiating the model and then storing it in LM. Okay. So this is the model. Once we have initiated that, we can fit our data. Calling this LM model. Okay, using that model, we are fitting the data and the data would be T and P. One is X variable and another is Y variable. Call the firstly calling the model and then fitting it with the data. Model is equals to lm.fit of P underscore P T comma P. Now, this is our model. Once the model is fit with the data, you can see the coefficient values. As I said, the model will give us the coefficient values. What are the coefficient values and intercept values? Say, this is our X, this is our Y. I'll show you the plot too. Okay. Now, time and potency. This was the data and this is the line the model found out. Okay. Now, the model found out a best fit line called y is equals to mx plus c. So the value of this m and c for the best fit line is given by the model over here. Okay. So we can use that for the further prediction. What would be the M? M would be the slope and C would be the intercept. Okay, this would be the intercept, this would be the slope. Model.coefficient will give us the slope value, M value. And model.intercept will give us the C value or intercept value. Y-intercept is nothing but the point where the line is intercepting on y-axis. So that will be given. By using that, you will be knowing the M value and also the C value. By using that, for any new X value, you can detect the Y. X would be time. So for any new time given, you will be able to predict the potency of the drug. Let me execute this line. Model.coefficient has given that the coefficient value would be minus 0.10. Okay, our M value is minus 0.10. Next, if I execute the model.intercept, this is giving me 99.3. So this is the value where the line is intercepting on the y-axis. Okay. Now, this is the equation we have got from the regression analysis model. If any new value of X is found, then the model can put it into this equation and can predict the Y appropriately. Model.score of T comma P. This will give you the accuracy of the model. The model is having 0.63% accuracy. The accuracy is a bit low compared to what normal models give. Now, we can take a new value. Say, for example, a new time we are taking is 10. For this value, if we want to predict the potency, we can directly use the model we have built called model.predict. So .predict will predict the Y values for the new X values. Okay. We'll predict this and store it in P_predict. So for the time T is equals to 10, the value of potency would be 98.2. This is how we can predict on new data. This is for prediction if there is only one new value. Next, we can predict for more values. Now we are taking a new data frame or a list of values 10, 13, and 14. Okay. X is a list which has 3 values 10, 13, and 14. This we are converting it into a data frame. The type of this was list. Next, we are converting it into a data frame. Okay, this is the data frame. After converting it into a data frame, we are converting the Y also into a data frame. Okay, now these are the new predictions. 98, 97, and 97 for the new values. After which we can concatenate. What is concatenation? Concatenation is nothing but the addition of two data frames. X and Y we are adding column wise, and the column names would be T and P. This will give us a new data frame, and we are storing it in that new data frame. Okay. Next, we can visualize this with the help of a scatter plot. This is the original data. Next, we can go for prediction data. Okay. Now, these were the original data points in our data frame, the blue ones. Okay, and the model predicted this straight line. Using this line, the model is trying to predict the new values. Okay, the yellow data points over here on the line, okay, you can say it is very small. Now, these yellow data points here are the new predictions for the new x values or time values. Okay. This is how we can build the regression models. Further part of the code we will continue after the break. Let's take a break for around 10 minutes. Okay, everybody, you can come back on 10:40. Hello everyone, hope you guys are back. So we were discussing about the code for simple linear regression and how the two variables are related to each other, that is time and potency. Okay, we built a model and then we predicted new data points using that model. So this particular graph over here is showing us the predicted line and the data points also. Okay, now moving ahead, we are again building this regression model and seeing the correlation between these time and potency. Okay, now here we are taking this data and building the linear regression model. But this time we are taking stats models.formula.api. Okay, we're taking this equation, this library, and taking OLS technique, that is ordinary least square technique, to find the regression. Okay, the same potency and time are the two columns we are considering and fitting the data. This library will help us understand it by taking the summary also. So using stats models.formula.api would be another, using another library and calling this function ordinary least squares, wherein we are passing the potency and the time and fitting the data along with it. Okay, so this is our model. Same data, we are just using different library. Now, model1.summary will give us the summary of the model. Okay, this is very important. This is where you are understanding how the model is built. Okay, now for this model, the R squared value is 63. Okay, and the intercept and the coefficient value. This is the intercept, this is the time. So the values for these are also given. Intercept value is 99 and coefficient value is minus 0.10. This also, again, we consider the p-value. Okay, if the p-value is significant, then only we consider those coefficients. This is the confidence interval. So the value of intercept can range from 97 to 100. Okay, 95% confident. And the value of time can range from minus 0.15 to minus 0.04. Now, seeing the summary, we can understand how well the model is and if changes are required. Now, our R squared value was low, it is 0.63. Now, predicting on time data. How to predict? We can use the same model, model1, and use the function dot predict. Predict would predict on the data you would be given. So model1 dot predict, giving the data frame and the time column to it and predicting. Okay. Let me execute this. And these results will be stored in pred1. These are the results. Now, Using this, we can calculate the error. We are calculating the root mean squared error. What is root mean squared error? Firstly, we said that in OLS technique, that is, this is the predicted line and these are the data points. If we calculate the average or take the mean of the errors, it might come as 0 because these are positive and these are negative values. Overall, if you take the aggregate value, it might be 0. So we go for other measures. Maybe we square them. But if we square them, again, the value becomes large. So we go for root mean squared error also. There is mean squared error and there is root mean squared error. How do we take the root mean squared error? We go for y minus y hat. Okay. This will give us the residuals. This, if you square them and take the mean of it, and then the square root of this, which will give us root mean squared error. Error would be actual value minus predicted value. That is nothing but y minus y hat. For this error, we are taking the square of it, mean of it, and then square root of it. That would give us root mean squared error. This is one way to calculate the errors. So, this is stored in res1. This is y minus y hat. This is the error. We are squaring those errors and storing it in res underscore square root of 1. Okay. So this is squaring those errors. We avoided negative values. Then we take the mean of the square. np.mean is a function in NumPy library. NumPy library is np over here. And then taking the function mean, and then it will calculate the mean of this value and store it in mean squared error. Then take the square root of it and then execute RMSE. So our root mean squared error is 1.28. Ultimately, we need less errors in our model. Lesser the error, better the accuracy of the model. Okay. Now, because we found that the data has a squared value which is low, and also the error, that is RMSE, is a bit high. So we are applying transformation technique. We are transforming the data so that it fits the equation. Okay. Transformation means we apply either square root or logarithmic or polynomial, any which way, which will better fit the data. Okay. So it here we are trying for logarithmic transformation. So for all the x values, we apply log, which will decrease the values, and that we will be plotting against the y values. Okay, it's just transformation. It is not changing the values on the whole. It is just transforming so that it better fits the line. Okay, now applying log transformation to the x. Our x value over here is time, and the y data, that is potency, we are directly taking it. Okay, this we are plotting it on the scatter plot. A resultant scatter plot looks something like this. Okay, these are the logarithmic values of x. These that is being plotted against y. Now we can find out the correlation between these two. the correlation has increased from minus 0.7 to minus 0.8. So after applying logarithmic transformations, there is better correlation. Okay. For this data, data where log was applied, we are taking that and building the model. Again, stats models formula.api. From that, we are taking this OLS, that is ordinary least squares technique, and then using this data, fitting the data and predicting. Okay, the results of this model will be stored in model2.summary. Now, the R squared value for this model has increased to 0.74. This is the intercept value and this is the logarithmic value. Ultimately, we have increased the accuracy and this relation is better. Okay, the log x values have a better correlation with the y, and by this we will be able to better predict. Now, we can use model2.predict and pass the data. This will predict the new values, and for that we can check for RMSE. RMSE is nothing but root mean squared error. Taking y minus y hat, squaring it, taking the mean and the square root, we can find the RMSE values. So our RMSE value is 1.07. So by applying logarithmic transformations, we have increased the accuracy and also decreased the error. To sum up whatever we have studied, we are building a simple linear regression model. Okay. This model we are trying to build for time and potency. How this time? The time is in terms of months. How the shelf life of a drug is affecting its efficiency or efficacy or potency. Okay. So for 10 months it is stored, what will be the efficiency? 20 months, what will be the efficiency? Which months have higher efficiency? So in that way, we are trying to understand the relationship between these two. Once we understand or get a equation, we can predict on the new data. Say other new drugs data found out, and then said that for 10 months, what would be the potency? For 12 months, what would be the potency? And so on. So we can use this equation and predict the y value. So we will be understanding the relationship between the two variables and then predict the shelf life of the drug, how we can increase the potency of the drug, and how much the drug should be manufactured. All these will be gained. All these insights can be gained. As all the ML algorithms, we follow the CRISP-MLQ method over here. First, we define what we have to do, the business understanding. Then we collect the data. Data can be collected again both in primary or secondary. Okay. After collecting the data, we are pre-processing the data. Data preparation. If there is any missing value, outliers, or any analysis, we can do it in data preparation phase. Then we can go for EDA. which is exploratory data analysis. In this EDA, we are plotting this data and trying to understand how the data is distributed, what are the patterns inside the data and all that. Here we have plotted the scatter plot to understand the correlation, and also we went for box plot. Once we understood there is a correlation, then we went for correlation coefficient. We got a good correlation between the two variables, which is why we moved ahead with simple linear regression. Applied this technique and we found out that R squared is 0.6, which was not a good fit, but moderate. So we applied logarithmic transformations and increased the accuracy and overall decreased the errors. This is regression. Next, we will be moving ahead with text mining. Okay. What is text mining? Where can we apply this? And how it is helping in Pharma? Now, yesterday we had seen there is different data types. One is structured data. Another is unstructured data. Now, the structured data is something which can be put into the tables. Okay, there is a particular structure in the data. This structured data will be helpful for the analysis. You can analyze this data easily. But unstructured data, so for example, there is a paragraph of text, or there are image data or video data. These all come under unstructured data. Today, we are specifically talking about unstructured text data, wherein if there is a paragraph of text or there are documents, a lot of documents with a text. How to do analysis on this text? Analyzing the unstructured data, text data becomes more difficult because there is no particular structure to it. So we apply text mining techniques to analyze this data. A lot of the data which we see in the day-to-day life is all unstructured data. Okay, so it becomes very important to analyze this particular unstructured data. Okay. Everywhere we see today is mostly textual information. Like say, for example, Twitter, blogs, news articles, blogs and articles, market surveys, online forums, Facebook postings. All these are textual data, which is unstructured. Huge amount of this data, if you want to analyze, you have to apply some of the text mining techniques. You can see there are scientific or technical literature, online reviews, email and correspondence, contact center notes or transcripts, surveys, chat. All these are textual information. A large major chunk goes into this. And a lot of techniques are being identified to analyze this textual data. Now, The agenda for this would be understanding the importance of text mining, understanding bag of words, terminology and pre-processing, DTM and TDM, corpus level word cloud, positive and negative word clouds, clinical trial projects. Okay. Whatever we see in our daily life, 20% of the data is structured, whereas almost 80% is unstructured data. So a lot of the data which we are finding in day-to-day life would be unstructured only. We'll be finding it in that text or document format, paragraph format, and analyzing that would be difficult. So you apply some of the techniques to analyze that. Where all do we get unstructured or textual data? Called transcripts. Call transcripts are nothing but in previous olden days where saving the call the recordings was not an option because of the storage, data storage. The calls were transcribed into text and this text were stored. So call transcripts, then then there is social media outreach, speech transcripts, field agents or salespeople, interviews and surveys. All these are textual data which are unstructured and it comprises a huge chunk. Okay. Now, what are we actually trying to do with these unstructured data? What are the firms actually looking for? We either try to search for the topics or themes. Okay. If there's a paragraph of text, then we go for identifying the topic or a theme of it. Or if it is related to the customer reviews. Okay. Like say in the online e-commerce platforms, you go for customer reviews. Then you go for sentiment analysis, opinions, attitudes, or emotions. Then you can go for relationships and our facts. Okay, I'm trying to understand the facts between this. Then there are name entities, then analysis, and we also analyze the metadata such as the authors. We try to analyze the phone numbers, etc. Okay, these are all the things which firms are looking by analyzing into the text data. Okay. Let's take a break for 5 minutes. It's 11:05. Let's come back at 11:10. Hello everyone. I hope you all are back. Yeah. So we were dealing with text mining. What is text mining? We try to mine or take the insights from the unstructured textual data. Okay. For this, we apply different techniques so that we can take the important facts from this. There are so many techniques we can apply, like topic modeling, sentiment analysis, all these which firms look for. That is one avenue where we can apply text mining techniques. Okay. So next, bag of words. Now, these are the different pre-processing steps which can be applied to the text data. As the same like a supervised and unsupervised model, wherein you are first focusing on the business understanding and then moving to data understanding, where you're collecting the data. Once the data is collected, you try to analyze it, and before that, you go for preparation. Okay. In data preparation phase, you will be applying the different pre-processing steps and also the exploratory data analysis techniques. Okay. Now, these pre-processing steps which we learned for the other models differ from what we apply in unstructured textual data. Okay. So we will be seeing these pre-processing steps one by one. Okay. Now, bag of words. What is bag of words? There's again one more technique which is applied. Here, firstly, we try to tokenize the text. Now, all the words are stage and all the men and women merely players. They have their exists and their entrances, and one man in his time plays many parts. So this is the text. For this, we will tokenize each word. Okay, tokenizing again is basically when there is a delimiter. Like say now the delimiter over here is the space. Okay. While applying this delimiter, all the words are split or tokenized or converted into tokens when there is the space delimiter. These tokens are then taken and the frequency of those words are calculated. Okay. Like the frequency of those words in this particular text. Now that is word. This is one to one. The word is repeated one time. Stage one time. Men twice. Men and man. Women once. Play twice. And exit once. Entrance once. So basically, what we are trying to do by doing this unstructured data, we are trying to give a proper structure to it. So all the pre-processing steps are behind this only to provide a proper structure. So the first thing we do is tokenize it, convert them into tokens, and then calculate the frequency of each word repeated in the document. This is nothing but a bag of words. Okay. Now, let us understand the terminologies when it comes to unstructured data. till now we were dealing with structured data. Now we'll deal with unstructured data and what are the terminologies specific to this structured data. In unstructured data, say there are a lot of paragraphs or a lot of text. All these together are called as corpus or corpora. Okay, and each row in this is called as a document. Even if there is an empty row also, it is called as document. So collection of all these is called as corpus, whereas each row will be called as a document. Okay, these are some of the commonly used terminologies in text mining. Corpus, all the collection of documents, and each row is called as one document. Now, what are the quirks or perks of using these? When there is typos or typing mistakes, spelling mistakes, you can use these models to correct them. Say MUSC is written for music. So these text mining techniques will remove these typos. Now, terms in lowercase, uppercase, and uppercase. All these can be identified as same. Then punctuations and special symbols, filler words, characters, pronouns, all these words can be avoided. Okay. Then there is another technique called stemming, where you will only keep the root words. Okay. You are trimming or stemming the words like jumping and jumped. Both, when applied with stemming, the word would become as jump. Okay. Next. Another technique is document term frequency and term document frequency. This is another pre-processing step which can be applied. Now, say you have Amazon customer reviews, okay, for a particular product. And now you're trying to analyze the text in those reviews. All the text data from those reviews you gather at a place, and now you're trying to understand the importance of each word in it and so on. So you have a collection of documents. For this, we try to understand the importance of each word. Say if the product is an electronic product and you want to understand what are the pros of it, what are the cons of it, or which part of it is most talked about in the review, or what is that people are looking out for in the product. All these things you can get from the reviews. But if there are a whole chunk of reviews, it becomes difficult to go through each review and come to a conclusion. So we directly apply these techniques, text mining techniques, to understand what exactly the reviews are about. Are they positive reviews? If positive, then what are they actually talking about? And if negative reviews, then what are they talking about? And so on. Okay. So for that, we use document term frequency and term document frequency, which will calculate the number of times a term is being repeated. Now, say there were 100 documents. Okay. In that, there were many tokens of words. The keyboard, USB, free, hard, all these. Okay. This is our frequency in which the each word is being repeated. So in the document 1, keyboard was repeated 4 times, USB 1 time, there was talk about free 0 times, and there was talk about hard 2 times. In like that, you're trying to see for all the documents what they are being talked about. Sometimes it might also happen that this next review might not talk about keyboard at all. One person might talk about keyboard, the other person might talk about complete different thing. So in such a way, you are trying to understand what are they talking about. Okay, so in the whole 100 documents, keyboard word was repeated around 200 times, whereas USB was repeated for 50 times and free was repeated for 100 times. This is the frequency of the word, okay, on all the documents. If we directly see the frequency, it may not give us complete picture. Say for example, out of these 200 terms the keyboard was repeated for, only one person, only one reviewer might have used the keyboard word for 100 times. So that might have increased the importance this word is getting compared to others. So to understand or to weigh the importance properly, we apply term frequency inverse document frequency. Okay, we not just see how many times that term is repeated in all the documents, we also give the weightage to the inverse of the document frequency. Okay. Now, so term frequency into inverse document frequency. The frequency, how many times the word is repeated in the particular number of documents, by inverse of the document frequency. Okay, so this inverse factor will show us how many times this particular word is repeated in each document. Okay, so it's like taking the mean of it and giving us the proper weightage of the terms. The term frequency inverse document frequency value increases proportionally to the number of times a word appears in the document. Okay, but is offset by the frequency of the word in the corpus, which helps to adjust the fact that some words appear more frequent in general. So if you are taking documents on this side and term on this side, then it is document term matrix. Whereas if you're taking term this side and document this side, this would become term document frequency. Just the complement of it. Next, we can build word clouds. Okay. So taking the whole corpus, we can build a word cloud so that we can analyze the data. This word cloud is visual representation. wherein the size of the words determine how frequently the words were repeated in the documents or in the corpus. Larger the size, larger the times or frequent was the time when this word was used. So corpus level word cloud. So we can build word cloud to get a quick analysis like what are the people talking about? The music, space, USB, game, all this are people talking about the Xbox. Now we can also perform sentiment analysis. So what is the sentiment and what is the feeling? If it is positive, what is the talk that people are telling? Then if it is negative, then what is the most talked about? So here also again, the size determines how frequent that is. So good, great are the positive words which were being talked about. When it comes to negative, it was hard to use. So sentiment analysis also can be done so that we can understand in the reviews that how the product is about or what can be improved in the product. Then we can even go for engrams. So engrams would be the contiguous sequence of terms. Okay. Now in word cloud, we are taking only one word, right? Music. So engrams, we are taking contiguous sequence of words like good music. So two words. So it will be bigram. In a sequence, we are taking two or three words and analyzing because just one word sometimes might not give us the full picture, like what is being talked about. So we can go for engrams, bigram, trigram, and then build a word cloud so that we understand what is being talked about. Next. Here we are seeing the example of clinical trials. Yesterday we have seen about the clinical trials. These are nothing but the study which is done before the drug is released into the market. When I say drug, it is drug or medicine. Before this is released into the market, uh, there are some studies which are done by the pharmaceutical companies. Why are these studies done? First thing is, um, when a drug is discovered, okay, when you say drug discovery, it's nothing but in a lab, researchers have found out a molecule. Okay, this molecule, so this is the molecule. This molecule now needs to be tested if it is working well, first thing. And second thing, if it is producing any side effects in the body. So to test this, they go for clinical trials. Okay, these medicines are first tested on animals and then tested on patients, and then once these are found to be safe, then it is released into the market. Now, again, in clinical trials also, there are multiple phases. Okay. Now, taking this molecule and First, it is given into the animals. Okay. This drug is tested on animals, whether the effect is found or not, and if they even check for the side effects. If this is cleared, then they go for testing it in humans. This clinical trials will be in multiple phases. First, they'll be checking it in animals. If it is found safe in animals, then they go for human testing. Okay. First, they'll check this particular molecule in a person who has the disease. Okay. Say if it is a medicine for diabetes, they'll check this tablet for people with diabetes. Then in the next phase of human trials, they give this tablet or this drug to the patient who not just has diabetes but also has other comorbid conditions like blood pressure or any other diseases, cardiovascular diseases. So, with the diabetes, he also has other diseases. For these, in these humans, also they test. Once this phase is also cleared, then they release it into the wider population, large market. Okay. If they were testing it on 10 to 20 people here, they increase it to 5,000 to 10,000 people. So, if they study on a wider population, the effect is better studied. Okay. You can get a more generalized result if it is studied on a wider population. Only once all these phases are cleared will the drug be released into the market. After releasing it into the market also, still the study continues. Okay. Post-marketing surveillance also continues wherein the pharma company will be reporting any adverse effects or side effects which the drug is facing, or these will be mostly given by the physicians or also the patients directly writing to the pharma companies. So these adverse effects are also taken, and the post-market surveillance is done. So each phase of the clinical trials is important, and if the drug is not able to perform in any stage, then the study will be terminated. Say, for example, in the human phase, first phase, wherein the drug was not able to produce any result and there were side effects, then the study will be terminated. Okay, the trial would be stopped, and the reason would be stated. The same way, in any phase, the trial can be terminated if a side effect or adverse effects are found in the trials. So, studying these documents and what was the issue faced becomes very important for the pharma companies. So, a lot of molecules get discovered and then they get into the trial phase. But a lot of drugs, the study might be terminated abruptly because of various reasons. And these reasons will be documented into the websites. Each country has their own website to document these, and people can analyze these texts so that further evaluation can be done and further modification can be done, and more safer drugs could be released into the market. Okay. There are so many stages in the clinical trials. The first stage would be testing it on the animals. Next stage would be testing it on the humans. This testing would be on the humans which have that specific disease. So, for example, you have produced a drug for diabetes mellitus, then you're testing it on diabetic people only. If it is found safer in stage 2, then it will be moved to stage 3, where humans who have other diseases along with diabetes mellitus, that is blood pressure, heart disease, all that. So people who have other comorbid conditions or other diseases also, for these also, it will be uh, decided and given. If the drug is found to be safer in these people, then it is moved on to larger audience. If the drug is not found to be safe in any of these steps, the study can be immediately terminated. Okay. Then in stage 4, it will be moving to the larger audience. Next, you can go for US FDA approval. Once the approval is done, it is released into the market. US FDA is the approval committee for US, wherein any drug which has to be released in the market has to be approved by Food and Drugs Administration in the US. So once it is released, it is still studied even after the release, which is called as post-marketing surveillance, and the adverse effects are checked. These are reported by either the pharma companies or the physicians or the patients. These are the multiple stages of the clinical trials. So at any stage, can the study be interrupted or terminated if the patient faces issues? So here we are seeing an example of a clinical trials project. Okay, how we can use text mining techniques in this project. What is text mining? Text mining is again dealing with unstructured data. So we are taking this unstructured data, performing some of the analysis so that the reason is understood. Okay. Now, overall, the objective for this project would be to increase the success rates of the clinical trials. Okay. Why are we doing this project? We want to increase the success rate of the trials. So we are analyzing the past data, like why some of the trials were stopped in mid. Okay. So our business understanding would be that we want to increase the success rate of the clinical trials. In the first phase, we need to collect the data from open source forums such as clinicaltrials.gov. Let me go to that website. This is the website. Here, all the drugs which are being studied, which are under trials, will be there. And what were the results, or what were the reasons why the study was terminated, all this will be given over here. Okay. You can find all the information over here. Now, we are collecting the data from the open source forums like this website which I have shown. There, we will scrape the data. Okay. So, data cleansing on XML files by extracting relevant fields from the clinical trials. We'll take the data from that website by scraping or extracting and then cleanse the data. Okay, mainly for the trials which have terminated, we go and check whatever the data is available and then try to analyze that. Okay, this data will first segregate into structured and unstructured data. This unstructured data, again, we perform different analysis, like we perform word cloud and sentiment analysis on unstructured data so that we can understand the reason why the trials were terminated. Okay. Word cloud is nothing but visual representation. You can pass the whole data and visually you can see the representation. In the word cloud, if the word is represent in a larger size, then it means that it is the most repeated word. Whereas the smaller size means it is not that important. Even in word cloud, the data will also be color coded. So in the same way, we can use it. So word cloud gives us an idea of which are the important terms that are being repeated. Then there is sentiment analysis. Sentiment analysis also can be covered after doing the workload. What people are speaking about, what were the positives, what were the negatives in that. What were the reasons for the termination of clinical trials? All these can be done. What all the techniques can be used? We can find out term frequency. How many times a term is being repeated in the reviews or in the documents. Then we can go for term frequency inverse document frequency. Okay. We will not just see how many times a term is repeated in the data, but also take the inverse value of frequency compared to the all the documents, like number of times the same word was repeated in different documents. So that is about term frequency, inverse document frequency. Okay. Next, there is positive and negative word cloud. We can build two word clouds to understand what are the positive words that are being spoken, what are the negative words that are being spoken. Once we structure the unstructured data, we can also build a dendrogram and other apply other techniques also so that we can get the interest variable. We can go for dendrogram, we can go for semantic network, or we can go for k-means clustering. This is how we can proceed with the project. Now, unigram word cloud and dendrogram. This is the data which was taken from the terminated trials, and word cloud was built. You can see the most repeated words were terminated, accrual, enrollment, efficacy. This is only when you take unigram word cloud. That is only one word. These were the keywords found out from this word cloud. Just by one glance, you can get a lot of insights if you build a word cloud. The keywords standing out of the rest are accurate, enrollment, slow, safety, efficacy, sponsor, lack, low, etc. So there were issues with the enrollment of the people, efficacy of the study, safety of the study, lack of uh, caution or lack of safety, low, etc. So these are the words which stood out. Now we have to see taking these words into consideration. We have to see this in terms of how we can gain business value from it. Okay, how it is going to help with our drug. So the business value has to be seen. Now, we can also see this word cloud in conjunction with the dendrogram. Dendrograms will be created in clustering. Okay, we saw K means clustering yesterday, but there is another type of clustering called as hierarchical clustering. Even on this clustering, you can build dendrograms. This will show the arrangement of the hierarchy and give the importance of each variable. Now, you can build a word cloud in conjunction with dendrogram. Okay, by doing that, we can notice that the slow accurate and slow enrollment and poor efficacy, sponsor funding seem to be the broad themes for termination of the clinical trials. It all depends on the hierarchy. But these were found to be the important reasons for the termination of the clinical trials. So instead of spending lots of hours analyzing the loads of data, we can just build a word cloud and a dendrogram and quickly get few insights. If we get some insights like, okay, this is what we have to focus on, then we can focus our models to that. So this will help with a quick check on the huge amount of words. Okay, then there is bigram word cloud. Okay, in bigram, we take two words. Okay, two words or contiguous sequence of words. Okay, study terminated, slow enrollment, low accurate. Just accurate was not giving us complete information, or terminated was not giving us complete information. In such cases, we can also go for bigram word cloud, which will give a bit more better insight into the data. Okay. So, contiguous sequence of two words from the example. Okay. So from here, one key thing is safety concern. Okay. At the first sight, it sounds as if safety concerns were reason for termination. But when we see in context, more termination reasons say that there are no safety concerns. Okay. Safety, just taking the bigram word, that is safety concerns, would give us a different picture. But if we go for trigram, then the word was actually found to be no safety concerns, which will take change the whole meaning. So this is how n-grams or different words taken together help us understand the context of the uh, data. Bigram is used to see two words to extract business values, and the key themes mentioned earlier are more evident over here. We can also go for k-means technique. Okay. Yesterday we saw scree plot in the k-means, wherein we see the clear bend or rate of change. Once there is the clear bend, that many clusters we try to cluster the data into. So, scree plot or elbow plot shows that there is a clear bend at two clusters. Okay. Hence, we can consider two clusters or categories that the data can be segregated into. Analysis is done considering the slight bend at second cluster and considering steep bend at fourth cluster. However, it did not provide any meaningful insights. Okay. Word cloud is clearly highlighting that this cluster is speaking majorly about accurate. This is a term referring to the number of patients in a study or clinical trial. Even a dendrogram is showing that accurate enrollment slow as a major cluster. Some of the highlights of these word clouds would be early and premature termination. Dendrogram also mentions majority of things related to premature closure of clinical trials. So the most words talked about are these. Then there are positive word clouds, which are giving the word clouds of the positive words and the frequency of the repetitions. To make this positive and negative word clouds also, you have to take the data, then apply the pre-processing steps, and then create the word cloud. Just to understand the sentiments behind what people are talking about, you are constructing these word clouds. To see this, you will need a data set which has the collection of positive words and also a data set which has collection of negative words. You can easily download it also from the internet. There are a lot of data sets which are there. Then coming to the pre-processing, different pre-processing steps have to be applied. So if you take a paragraph of data, then you will have to first tokenize it, create it into tokens. Then there is something called as stop word removal also. In a paragraph, there might be some words which are not useful, which can be removed from the data, like is, was, to. All these are stop words which don't contribute to our word cloud, and it will just clutter it. So we are removing these stop words. For the removal of these stop words also, we need to download a dataset which has a collection of all these stop words. Okay, this is also available online. Once you have removed the stop words from this paragraph, tokenized it, then you can apply stemming or lemmatization. What is stemming? What is stemming? Would be to stem the root word. Okay, if the word is playing or if the word is running, you're trimming the word and just keeping the root word play, run. So stemming is uh, stemming the other part of the word and just keeping the root word. Lemmatization is also the same, wherein you are keeping the root word, but lemmatization has an intelligent way of doing it. Okay. Sometimes when you are trying to trim or cut in stemming, the tense or the words tend to be cut improperly. Say, for example, amazing. If you take the word amazing and if you apply stemming to it, this word becomes um, amaze. In stemming, it will improperly stem the word to amaze. There is no E here. But if you apply lemmatization to this, then it will intelligently understand that this is the word amaze. It will search its documents and come back with the vocabulary which has amaze word. Okay. So lemmatization is an intelligent way of applying these techniques. Once you have pre-processed all these data, then you can apply the word cloud. Word cloud can be applied, simple word cloud can be applied, and you can even go for sentiment analysis where you're preparing positive word clouds and negative word clouds. The same way, whichever is a high or very frequent word will be represented in the larger size. Okay. So in the negative word cloud, problem was most repeated word, worst, disappoint, bad, all these were the most negative repeated words. So here we try to understand what are the different sources where text data is being generated. Then we understood how to give structure to the unstructured data, that is unstructured text data, using bag of words. We learned about the terminology used in text data analysis. Then we learned about document term frequency and term document frequency. We learned about TF-IDF and its usage, about word cloud and its interpretation. Okay. Next, we will be moving to the code part of it. Okay. So, this is the code we will be dealing with, text mining. Now, I have opened this code in the Google Colab. Okay, this is another IDE we can use for writing Python codes. Okay, very easy to use and you can do it online. You don't have to install it in your system. You can just open it in your browser and run the codes. Now, in this use case, we are applying text mining on data. But for that, we need to get the data. So getting the data from these websites, we can do it by line web scraping methods. Okay. The problem statement we are trying to solve over here is to see the reviews of the drugs. Okay. We are trying to extract reviews of drugs from drugs.com website. There's a website called drugs.com. Okay. Here, all the drugs are written and also their reviews by the customers are also written. If you want to extract data from any website, you will have to apply web scraping techniques. Now say this is one drug, Actemra. Okay, this is a tocilizumab drug. Now, if you want to extract this data, you will have to go for web scraping. So for web scraping, there are different libraries available in Python. We are using Beautiful Soup library. Okay, Beautiful Soup is the library we are using to extract or pull the data out of HTML or XML files. Now, Beautiful Soup is a Python library for pulling data out of HTML and XML files. It works with your favorite parser to provide idiomatic ways of navigating, searching, and modifying the parse tree. It saves programmers hours of days and works. Instead of copy pasting or writing these all, you can just go for scraping this particular web page. Okay. Now, problem statement is we are trying to extract reviews of drugs from drugs.com. The objective would be text mining analysis using review sentiment. Constraint would be to perform sentiment analysis to prepare word cloud. Here, the data we have taken is the scraped customer reviews data on the drug Xanax using Beautiful Soup. You are using the library Beautiful Soup and taking or scraping the customer reviews on the drug Xanax. Let me go back. Let me search for the drug Xanax. Okay. This is the drug we are trying to extract the reviews for. Now, let me go to the customer reviews section. Okay. This is the page which has the customer reviews for Xanax. Each person has written some of the reviews, what they are using, what they have faced, all these reviews. Okay. Now, you can see here, there are so many reviews and the pages keep continuing. Okay. There are a lot of pages with the reviews. This is the next page I'm scrolling through. And the count keeps going. So we are writing this code to extract all the reviews that are written in multiple URLs. Now, the necessary libraries are being imported over here. So we are importing the library requests. Request is necessary to extract the content from any URL. These all code is mainly for the web scraping. From BS4, we are using a beautiful soup. Okay, we are calling the library beautiful soup, and also we are calling it and naming it as BS. So if we want to use it on the later part of our code, we will use it as BS. Okay, beautiful soup, as we studied, we will be using it for web scraping. RE is the library for regular expressions. Okay, whenever we want to extract data from the strings, we can give some of the expressions and extract that particular data. So regular expressions are very important when it comes to text data manipulation. Then we are importing matplotlib.pyplot as PLT, which is the library for data visualization. And then we are importing word cloud for word cloud preparation. These are the different libraries. If we have to run a cell in Colab, we just write the code part over here and then click on this. Okay. So this cell got executed. So we have imported all these libraries into our session. Now, the later part of the code we are writing is for scraping the data from that website. Okay. Drug underscore reviews is equals to square bracket. This means we are creating an empty list called drugs underscore reviews. After creating this empty list, we are starting a for loop. Okay, for I in range of 1, 25. In this for loop, the range we have mentioned is 1, 25. So it starts from 1, 2, 3, 4, and until 24. It takes the value of I. Okay. Now, again, another empty list we are preparing called IP is equals to square bracket. This will create another empty list called IP. Then we are asking it to go to the URL. Okay, the URL which we mentioned here is this. Okay, whatever website we want to scrape, we take this URL. You can see. I'm sorry. We take this URL and then we will paste it over here. Okay. After that, we are adding a string for this every value of I. Now, request library will get this URL. It will get the permission from this URL to take the data. BS is the beautiful sublibrary, and from that you are asking the response to get the content from the HTML. Okay. So we are creating a soup object to iterate over the extracted content. Now, this reviews will go for I.find of P. So for I in soup.findAll, it has to go to the div section of class, this one, and extract data for every I. Okay. Then for div in soup.findAll, it will go to the div again and go to the section wherein it will find this div and extract the data from there and store it into the IP. This is the IP we have created. So this goes on for every I in the until the 25 range. Okay. Now, what are this div class or class? What are all this? Now, if we see this HTML page, if you have to extract a particular segment of it, let me go back. Now, in this HTML pages, each thing is written in particular segments. If you want to see where it is particularly written in HTML code, you can just right click and go for inspect. Okay. The HTML code for this particular web page opens up. So this works on for any URL. You can just go there and check for the HTML. Now, if you want to know where these reviews are, you can just click on it and inspect it. Okay, this is where the highlighted part, this is where your reviews are stored. So you have to mention the class where it is stored and under which heading. Okay, all this you will have to mention. So once you mention that, it will be able to understand from where it has to extract the data, and this data will be extracted and stored in the form of a list. Okay, this data will be extracted and stored. Now you are adding this list into the drugs review and then iterating for all the other reviews. So drug reviews plus IT. Then adding the reviews of one page to empty list, which in future contains all the reviews. So all the reviews get stored over there. Once it is stored over in the list, you are writing it into a text file. For that, we'll open a text file. With open, the name of the text file is oneplus.txt. W indicates we are writing in the file and encoding is UTF encoding. So as output, we are giving the drug underscore review string in the output. Okay, so this whole thing will be written in the file. After writing it, we are joining all the reviews into a single paragraph. Okay, IP underscore rev underscore string is equals to space dot join of drug underscore reviews. So all the spaces will be joined and the whole reviews will come under one paragraph. Then we are asking for the output. Okay. So if I execute this, all the reviews from that website will be extracted and then it will be stored in that list. This particular code is being executed. Now, the tick mark beside it indicates that the particular line of code got executed. Okay. Now you can see this is the review part which was extracted. Okay. So all the reviews from that page got extracted and got stored over here. Now, from all these reviews, can you tell what are the patients speaking about? Is the drug effective? Do they face any issues or not? You will have to go through all the reviews, and that takes a lot of time, right? You have joined all the reviews wherever there was space, you have joined them. So for that, we will go for applying text mining techniques. For that, first we'll apply all the pre-processing steps. Okay. So we have, however, stored it over here. Next, we are trying to get the data set of stop words. Okay, so we are downloading stopwords file from GitHub. This is the code to get the file from GitHub. Executing this, the stopwords will be stored in the sessions memory. Okay, now you are using NLTK library. Okay, natural language toolkit library, so that we can perform the further pre-processing steps. Firstly, we are using the regular expressions library to remove any unwanted data or symbols in the text. Now, re.sub is substitute. So whenever there is this particular arrow indicates negation. So negation of Z means it is telling that whenever it is not alphabet, okay, anywhere from A to Z, if it is not alphabet, then it has to be taken and substituted with a space in the string IP_rev_ string. So we have converted that into string so that we can apply regular expressions on it. And then whenever there is anything other than the letters, we are converting that into space. After doing that, we are telling it to lower the case. So dot lower will take all the words into lowercase or small letters, you can say. This is one part of the pre-processing. Then if there are any digits 0 to 9, then also it will be replaced by space in the reviews. After doing that, we are splitting the data whenever there is delimiter space. Okay. So now in this review data, what happens is if there is anything which is other than alphabets, it will replace it with space. And anything which is numbers, that also will be replaced with space. And then after doing all this, it will convert all these into lowercase letters. And then it will tokenize or split the data whenever there is space. Okay, for every space, the data will be split. In short, we are converting them into tokens. After converting them into tokens, we are finding the term frequency inverse document frequency. So we are finding the TF idea to understand the importance of the word in the word clouds or in the reviews. So to apply TF-IDF, we are importing TF-IDF vectorizer from the library sklearn.feature_extraction. From there, we are initiating the TF-IDF vectorizer. Once we are initiating that, we can use that to fit the data. Okay. So all the words, first we have converted them into tokens. After converting them into tokens, we are vectorizing it. Okay. Now, vectorizer will see the term frequency and inverse document frequency for each token and then vectorize them. Okay. After factorizing that, we are taking the stop words text. Okay. Using this and reading the stop words. Whenever there are stop words, we are trying to split the data. W for W in IP underscore reviews underscore words, if not W in stop words. Means if the W is not in stop words, then it is kept in this list. If it is in stop words, then it is removed. After that, all these reviews are being joined into one string, and that will be stored in IP underscore rev underscore string. Okay. Once this is done, we can build word cloud for the whole corpus. Okay. This is the word cloud we are building for the whole of the reviews. Okay. So we are passing the function word cloud. Background color, we are denoting it with white. Width of the word cloud has to be 1800, height is 1400. You can define whatever measurements you want. And generating the word cloud with the data in IP underscore rev underscore string. Then once this is generated, when you say plot.im show, this will use matplotlib library to create this word cloud. This is the word cloud for the whole corpus. Okay, for the whole data. By this word cloud, you can see some of the most important words. One is anxiety, which is being repeated most frequently. Then there is Xanax. Then there is the word depression. Then there is the word drug. Okay. By building a word cloud, you can see just in one glance, you can understand a lot of insights in the data, like which is the most spoken thing about a drug, which is the most issue faced by a person using the drug, and so on. Okay, this is the word cloud which we built for the whole corpus. Now we can build a word cloud only for the positive words. So for that, again, we are downloading the positive words document from the GitHub. Okay, this is the code to get the positive words from GitHub. Okay, so this is downloaded and it is saved to positive-words.txt. Okay, here you can see in the runtime. Can show you this. This is the document for all the positive words. Okay. So what happens is we can check our data and see what are the positive words from this document and then build a word cloud. We can also go for stop words. These are the stop words. Did, diff, do, each, all these words which are not relevant or not used. So we can remove these stop words from our text. Then there is one plus dot text. This is the text we got in the beginning. Now, we are taking the positive words document from the GitHub and then opening the document. Okay. With open, we'll open the document, positive words, and then read it. Okay. Read it as POS. So positive.read.split. Reading that and splitting that. Now, next we are writing a line of code wherein we are choosing only the positive words which are present in the positive words document. Okay. So this is a list comprehension method. Okay. We want word. Which word should it be? It should be for word in IP underscore rev underscore words. This IP, whatever word is in IP underscore rev underscore words, if that word is in POS words, that is positive words, then only we want that word. And this word should be joined in this IP underscore POS in underscore in underscore POS. Once we get the list of all the positive words in this document, we are building a word cloud. Yeah. So this is the word cloud. Initiating the function word cloud, background color we asked it to be white, width should be 1800, height should be 1400, then generating the word cloud with this data. All this will have only the positive words in the reviews. So plt.figure of 2, plt.IamShow of word cloud. So it will create another figure and show a word cloud. Okay. These are the positive words. It helped. Is one positive feeling people were facing, people felt. So this is the most repeated or frequent word. Miracle, amazing, wonderful, calm, love, one. All these are the positive words. Yeah. Let us give it some time to execute. So this is the word cloud for only the positive sentiments. Next, in the same way, we can build a word cloud for the negative sentiments too. Okay, so downloading the negative words text file from GitHub. Can download this. If you want any new words to be added which are not in that text, you can create a document and then upload it so that the new things will get updated and then use it. So the negative words get updated. So these are the negative words. Abrupt, abrasive, absurd, abused, accost, accursed. All these are the negative words which are defined. Now we'll write a code so that it opens this negative word document, and whichever word is present in this document, we will, and the word present in the reviews, we will take that word and build a word cloud. Okay. with opening the negative word text file. Reading this, R represents reading it as neg. Okay, so neg dot read will read the file and split whenever there is new line character. Okay, this will get stored in neg words. Okay, so we want a word. This is again a list comprehension method wherein we are storing word for which word? For word in IP underscore review underscore words. Okay. So it will store only those words which are in the IP underscore review words if they are also present in if W is also in neg words. Okay. Then only it will be put in the list W and then it will be joined. Okay, this joining will also be with the space so that every word is accompanied by a space. This will be stored in IP underscore neg underscore in underscore neg. This we are using to build a word cloud. This word cloud, we are representing it with a background color of black. Width should be 1800, height 1400, then dot generate will generate the word cloud for the data we are providing. This is the data we have given over here. Okay. So this is the figure 3 and we are showing the word cloud for negative words. So we can see there are a lot of negative words. The most spoken negative word is anxiety, depression, panic attack. All these are the bad reviews of the drug, or these are the side effects people are facing. Okay. Now, larger the size, greater the frequency of the word appearing in the text. Next, we are using NLTK library, Natural Language Toolkit library, and downloading WordNet and Punk. Okay. Let me execute this. After this, we are importing an NLTK, and from the NLTK, we are downloading this. Okay. Now, we are using this to create word cloud with bigram, mean 2 words. Next, from word cloud, we are importing word cloud and stalwarts. From NLTK, we can use WordNet lemmatizer. So this lemmatizer will help us get a root word. If it is amazing, we will get the root word amaze from it. This is an intelligent way of getting only the root words. Okay. Then we can go for lowercase. I mean, this is a way of normalizing the data. Okay, taking the whole data and this is unstructured data normalization, where you're converting the whole text data into lowercase and then you're tokenizing it. Yeah. Now, next, you are replacing this with the space. Okay. Because it will create problems with the tokenizer as tokenizer finds a delimiter to tokenize. Next, you can remove the extra characters and the stop words by using regular expressions, array.split, where all it has to split any character like this, all these characters you're defining, and if it finds it in the text, it is going to split. After splitting, we are trying to remove the stop words. Okay, set of stop words will convert it into a set and store it in stopwords underscore WC. Then customized words, price and grade, or also uh, joined or you are adding these two words also into the stop words to be removed. So union, creating the union and putting it in new underscore stop words. After which you are taking the words for all the words in text content. If those words are not in the stop words, then those words will be stored in text underscore content. Once that is stored, you can take all the words in the text content whose length is not equal to 0. If there are some spaces, those will be removed. After taking those empty spaces or empty entries, then we can lemmatize it. WNL.lemmatize of T for T in text underscore context will lemmatize the whole reviews and then tokenize it, then create a bigram. To create bigram, we can again apply the bigram function from nltk.bigrams to text content and then store it in bigrams underscore list. Now, these are all the bigrams which are formed. Severe anxiety, anxiety severe, anxiety panic. These were the most used words in sequence. Okay. After that, we can go for creating a dictionary and then vectorize it. Vectorizing will show us how many times each of the word were repeated. So severe anxiety was repeated for 343 times, started child 340 times, and so on. Then we are calculating the bag of words. Panic attack for 57 times, panic disorder for 43 times, anxiety panic for 20 times. So bag of words is giving the frequency of how many times the words were repeated. Because it is a bigram, we have two words in sequence. After doing all this, we are giving the word cloud. Okay, we're giving the code to generate word. Creating the dictionary of the words, then mentioning the height as 1000, width 1500, and the max words which we are using to generate this is 200. We are not using more than 200 words. Okay. And then generating the word cloud with a dictionary. PLT is again using matplotlib library to show the most frequently occurring words in the bigram. Okay. So panic attack, anxiety, depression, panic and anxiety. All these bigrams are the most used words. Okay. So what did we do? We did unigram analysis first. we saw that they were having a lot of negative reviews. After that, we did a sentiment analysis to find the positive and negative sentiments through reviews. Then, to get a clear idea of what the person is exactly speaking, we went for bigram. After going to bigram, we got it more clear what the reviews are talking about related to panic attack and taking Xanax helps. Now, this is how we can use text mining for sentiment analysis and also to get a clear picture of the reviews. To sum up about all the things that we did in text mining, let me go back to the page. So in text mining, we take corpus of the words. Corpus is the collection of documents. This corpus, we try to pre-process. Okay. Now, the documents are pre-processed. Pre-processing and unstructured data follows different methods. Okay. First, we need to split the data into tokens. Okay. If there is a document or there is a sentence, we split the data into tokens whenever there is a delimiter. A delimiter can be a space or any other character. Okay, whatever delimiter you mention, based on that, the words will be split into tokens. Next, we can also normalize the data by converting all the words in the corpus into one normal form or same format. So either we can convert the whole data into uppercase or whole data into lowercase, but it should be in a normalized format. Why are we doing this pre-processing steps? So that these tokens, which we find, or the unstructured data can be converted into structured format. Okay. Paragraphs can be converted into tabular form. What are the different techniques that can be applied? One is what we saw as tokenize. Next, after tokenizing the words, we go for bag of words also. What will bag of words do? Will give us the frequency, how many times each word is repeated. 1 time, 2 times, all that. Again, it is converting it into a structured format. Then we can also go for TF-IDF vectorizer, wherein we are vectorizing the data. How much importance has to be given to each document in each review? Okay, if say one word like keyboard is repeated 100 times, how much importance should this word be given in compared to all other words? That depends, or that is calculated using T of IDF vectorizer. Then we can go for stemming also. Stemming is a way to get the root word after a stemming or trimming. Okay, like for example, if the word is amazing, we can crop this or stem this word to amaze to get the only the root word. But then the drawback of stemming is that it just directly stems or trims the data, which is difficult. That is why an intelligent way to do the stemming would be lemmatization. Intelligent way of stemming, wherein the lemmatizer has a text of words and it reviews from those words and gets the word in question. Okay, it gets the amaze word from the dictionary or the corpus it has. So it is an intelligent way to get the data. Okay, this is about stemming lemmatization. We can also normalize it to the same format. And once you have got all the unstructured data into the structure, then you can apply whatever techniques are needed for to solve the business problem. Okay, we can apply clustering, we can apply SVMs, we can apply neural networks, anything that is needed to solve the business problem. In our example, we have applied different pre-processing steps and then went for sentiment analysis. Okay. We have taken the corpus of words and then built word cloud. After building word cloud, we have also taken the reviews of the medicines and then checked for the sentiment, the positive words and the negative words. Built a positive word cloud, then we built a negative word cloud. Okay. Now, this positive word cloud and negative word cloud give us a picture into the reviews, but then it didn't give a lot of clarity into it. So, what we did is we created another corpus. We took another corpus and then we applied pre-processing steps for this time with bigraphs. We took two words in sequence and then applied all the pre-processing steps. We have removed the stop words, we have removed the lemmatizers, then the stemming, normalized the data, and all this to get two words, that is bigraph. We have done the TF-IDF vectorizer to understand the importance, and to even understand how many times both the words were repeated together, the frequency of both the words. With this in grams, we built the word clouds for positive and negative sentiment. This also gave us a better insight into the reviews, what the patients were actually facing and what were the reviews. So, taking unigrams, taking bigrams, and taking trigrams depends on the use case you are trying to solve. But taking these gives a more better clarity on what the text is all about, or what is the context of the text. So this is how you can apply text mining techniques to extract the data and then pre-process it and get the reviews. Now, by this, we come to the end of our lecture. So basically, we saw how pharma is helping in and how pharma is being benefited by the analytics and where all we can apply this analytics knowledge in pharma and how can we help with a better patient care. Next, we saw about the CRISP MLQ methodology, which is a standard process which is followed for all the data science project managements. Now, this CRISP MLQ has 6 phases, and all these 6 phases will be followed whenever you are working on a project. First involves a business understanding, wherein you're trying to understand what the business is trying to do, and then data understanding, where you collect the data, understand the data. Then we go for pre-processing the data, clean it so that you can analyze the pattern in it, then send it to the model. So next phase involves model building. Once we build the model, we can evaluate if the model is working well on. We have evaluated the clustering models by silhouette coefficient, regression models by R squared, and we have seen if the errors are less or no. For the errors, we have calculated RMSE. Then, after evaluation, we can deploy the models into the software, integrate them into the software, and then monitor it continuously. Why do we need to monitor? We need to monitor because the accuracy tends to fall down with time as new data comes in, the accuracy tends to fall. So you need to retrain the model every now and then. So constant monitoring and maintenance is important when dealing with new data. Once we were done with the CRISP MLQ, then we discussed about the different machine learning algorithms. We saw the supervised learning models and unsupervised learning models. Supervised is where we have output variable. So we train the model with an output label and then try to predict this output for the new data. Whereas in unsupervised learning, we don't have the label. So we are just summarizing the data into different groups. Different techniques, different algorithms are present in unsupervised. In unsupervised, we saw the clustering technique. Clustering also again has many different methods. We only saw about the k-means clustering. K-means clustering will identify the most similar data points and cluster them in one cluster. So K in K-means indicates the number of clusters, and the number of clusters you define, the whole data will be clustered in those many clusters. Once the clustering is done, you can take the new data and put it in the clusters defined. Then coming to supervised learning. In supervised, we saw the regression, wherein we tried to find the relationship between two variables with the help of a straight line. So linearly dependent variables give us better accuracy. So this dependence we try to check with the scatter plot or the correlation coefficient. And if there is dependency, then we build the linear regression model, which gives us a straight line equation. This is our best fit line, and you can predict new data with this line. So linear regression was done to predict on new data. And the model was evaluated based on R squared and root mean squared error. If the R squared value is more and RMSE is less, then the model is found to be good model, and the line is the best fit line. Next, we moved on to the text mining. This text mining techniques are mainly for the unstructured textual data. So unstructured textual data is the important point over here. The data which is not in the structured or tabular format, which is in paragraphs. This data is difficult to analyze. So we try to make it into structure and then analyze the data. This is about text mining. So we have only seen a few use cases where domain knowledge can be used in analytics. And because the pharma domain is growing exponentially, now integrating analytics into it is going to create wonders and going to innovate a lot. Like there will be a lot of innovations coming up in the field of pharma, and having the domain knowledge will add up to the skill set. So this is how you can use pharma knowledge in analytics field. I hope you got a clear picture on the analytics and how to use them at the pharma. So this calls to the end of the session. Thank you, everyone.